Hey y'all, welcome back to Math Rescue. I'm Andre, a certified math coach. In this video, we're going to talk about expanding binomials, specifically how to use Pascal's triangle to make it fast and organized. I'll show you how to build a triangle, how each row connects to the powers of your binomial, and how to expand any expression without missing a single term. Once you see the pattern, it's actually kind of satisfying. Let's talk about it. All right, so here we have a problem. First of all, let's start off with the vocabulary for the skill. So this skill is called expanding binomials. Here we have a binomial. A binomial is a thing, a polynomial with two terms. And we want to expand it. What that means is we want to apply this exponent to it. So this means that we have x plus y times x plus y 6 times. 6 times multiplying itself. You could do other tricks. So, like for example, you could multiply these two and then take that result and multiply it by another x plus y. But that is going to take, I'm sure you can imagine, that is going to take forever to do. So there's this idea of expanding binomials, and it gives us an entire shortcut for multiplying these out essentially. So the first way I'm going to show you how to do that is by using Pascal's triangle. Here's the beginning of Pascal's triangle. The reason why Pascal's triangle helps is because it gives us the coefficients of every single term for what this multiplied out would be. By the time I get to the end, you'll see what I mean by that. I promise. Before I can continue, I need to write out a little bit more of Pascal's triangle. So this would be to the 0 power, this would be to the first power, this would be to the second power, this would be to the third power. So I need to go one more. I'm sorry, I need to go a few more. 5, 6. We want to get all the way to the 6th power. Let me show you how to expand the triangle. So the way we get the triangle is by adding these two values, and they make the value right below them. And we're always going to have one on the outside. So if I add 1 and 3, I get 4. If I add 3 and 3, I get 6. 3 and 1, I get 4. And then another 1 on the outside. And we just kind of continue that pattern. 1, 5, 5, 1. There are a lot of interesting patterns that emerge with Pascal's triangle. A lot of very interesting numbers that related to different areas of mathematics. It's actually pretty crazy. It's definitely considered one of the mystical aspects of mathematics. And there's a lot of studies that have gone into breaking down all the things that you could do with Pascal's triangle. One of them is binomial expansion. All right, so here we have the coefficients that we want. 1, 6, 15, 20, 15, 6, and 1. So check out how I'm going to use these. So let me first start with writing those values down. I'm going to write 1, 6. I'm leaving some space in between them because there's going to be more writing that happens. Ooh, writing a little bit too big. Okay, cool. I had enough space. Then the next thing I want to do is I want to start writing my exponents. So this is going to start off at the 6th power, and it's going to end up at the 0th power. So let me go ahead and record that. 5, 4, 3, 2, 1. Then I'm going to go ahead and do the y value. So y is going to be the opposite. So y is going to start off at 0, and it's going to end up at 6. If I had a negative here, I would be sure to kind of alternate the signs. But since it's positive, I don't have to worry about anything too complex right now. So we get y to the first, y to the second. Some of these are really close. I didn't really leave enough space. Y to the fourth, y to the fifth, and then I already wrote y to the sixth. Then I'm going to go back through. These are all these are different terms, so I want to separate them with my addition sign. And then I could clean it up. So like, for example, anything to the 0 power is just going to be 1. And if I'm multiplying things by 1, the 1 could just disappear. So I can make this one disappear, and y to the 0 is also 1, so I can make that disappear. Y to the first power is just y, so I don't have to show that it's to the first power. Same thing over here, x to the first power is just x, so I don't have to show that it's to the first power. And then I can make this red one and this blue one disappear. And we've officially expanded that binomial. That would have taken forever to do without Pascal's triangle. I'm Andre with Math Rescue. See you in the next one.